right. Uh, so welcome to yet another YoungWonks live. Today we are going to be talking about capacitors, how they work, and their uses. So this is continuing from what we did last time about resistors, voltage, current, and the basics of electronics. And today we are going to focus on a component which is used pretty much in almost every electronic circuit, and it's called a capacitor. Now, the first thing to do is try to understand the word capacitor, right? The capacitor word comes from the term capacity, and it is a device that can store charge in a circuit, right? Now, why would you want to store charge in a circuit? So there are many uses for this, and we will get into each one of these one by one, right? So as we discussed, a capacitor is a device that is used to store electric charge. Now, the way an capacitor is designed is that you see that it has two terminals, and this is just one type of capacitor that we see on the screen. It's called a electrolytic capacitor or a polarized capacitor. But in general, the way it works, and this continues from our discussion about insulators and conductors from last time, is that it's basically two conductors connected to two terminals with an insulator in between. Just to recap, an insulator is a device that does not conduct electricity, and conductors are basically devices that can conduct electricity. Now, the 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 capacitor is basically a two-terminal device. Some of them have a polarity. That means that in this case, you can see there's a longer leg and a shorter leg, and the longer leg is the anode or the positive, and the shorter leg is the cathode or the negative. And to be able to understand this a little better, we will look at it in a circuit as well, and I'll show you a demo where you can even understand this better. Right now, you can see the capacitor is labeled with 47 microfarad on it. Right, the unit of capacitors, capacitance, or capacitors is microfarad. Now, microfarad or farad, in this case, generally we have capacitances to be small values, and that's why they could be microfarad, nanofarad, but farad is the unit of capacitance, and this is based on a scientist named Faraday, whom you may have come across in the context of radio communication. Now, we do have different types of capacitors, and I've just listed a few over here. And you may have seen a lot of these in different electronic circuits if you had a chance to open it up and look at it. Electrolytic capacitor is what we saw, and I have a few of these and I'll show you them too. A paper capacitor is because paper is an insulator, and you can have two metals and you can basically roll it up such that there's paper between two metal contacts and cover that up. In the same way, you may have a film where there may be an insulation film that is there, and a ceramic capacitor as well, which has a ceramic disc. All these are basically talking about different types of insulators that are available on these capacitors. Now, these different ones are used in different contexts and are serve a different purpose in each scenario. Now, let's take a look at the parts that are needed for our current circuit. So we're going to use a breadboard, we're going to use a resistor, we're going to use a LED, a button, a capacitor, battery as well, right? And we will understand how this exactly works, and I'll give you a demonstration of what it looks like, and then we will see its practical application as well. So as we talked about, the unit of capacitance is farad, and this could be measured in terms of farad, microfarad, millifarad, nanofarad, and in larger context, even megafarad and stuff like that. The symbol that is used in electronic circuits is two parallel lines with a separation, which is similar to what it looks like, is that there is no direct connection because there's an insulator in between, but due to the voltage applied across its terminals, charge builds up along the two terminals, and that is immediately discharged when there is a path for it to discharge and there is no external supply being applied. This will be more obvious when we get into the, the explanation in the next slide. So this is the circuit we'll be looking at. You have a power source, we have a switch that we can toggle on and off, we have a resistor in series with a LED and a capacitor in parallel. Okay, and we're going to build this as well. And so to understand how a capacitor would operate in such a scenario, we can take a look at the animation that's on the next slide. So as you can see, the moment a power supply is applied, charge starts building up on one of the plates of the capacitors and the voltage starts building up. And the moment the voltage is equal across the LED and the capacitor, it's going to stop. And the moment we switch off the power supply, it is going to discharge through the path available through the LED, lighting it on for a fraction of a second. I mean, this really depends on how much capacitance is there. More capacitance, more the ability to store charge, and longer the time to discharge. But in the same way, more the capacitance, more time taken to charge, and in case you don't actually have the circuit running for that long, it can not really charge up and you will not really see the impact of the capacitor in the circuit at all. Right? Notice how when the switch is turned off, the discharge of the capacitor happens through the available path and it continues until the charge across both plates of the capacitor are equal. Now let's try to get into building this, and we'll first, to be able to understand this, because this phenomenon may not be as obvious on an actual circuit, what we will do is try to look at it on Tinker circuits as we usually do. Now here I have a battery. I'm going to use 4 of them, and that's going to give us 6 volts. And as usual, I'm going to start by powering my breadboard with power and ground. I also like to use the right colors to indicate the battery as well. So let me first, as usual, you want to get power onto your breadboard. That makes all the other things much easier. And ground is always useful to set it to black, and power is generally red in color. Now the next thing that we're going to do is bring in this button, and we will talk more about the button in the future, but for now what we want to understand is the button is kind of like a bridge. If the bridge is closed, then vehicles can pass through. If the bridge is open, you have to wait for the bridge to close for any vehicles to pass through. In this example, vehicles being charged. Now, the next thing that we want to do is we will connect the positive to one end of the button. The other end of the button is going to have a resistor, which is then going to connect in series to a parallel connection between the LED and the resistor, and the other end of the resistor or the parallel connection of the LED and the capacitor is going to connect to ground. Now, what is going to happen is that when you press, and you're going to look at this, and when you turn this on, it's going to work like a regular LED circuit. What you can notice briefly is that when you let go of this button, the LED does not turn off instantly. It takes a few fraction of a second to turn off. And this is the property of the capacitor that really helps us use it in the way that we would want to use it. Now, to understand this phenomenon again a little better, I'm going to use this voltmeter. And I'm going to connect it across the capacitor for us to be able to understand the capacitor better. Let's see, I think I want to connect the other terminal to it. So I'm going to connect. Yes, so we will connect. So as such, the negative terminal can be connected to any negative, right? And the positive terminal can be connected to the positive. And now let's see what happens. So initially, you can see that it's slowly building up charge because there may be some leakage current in there. The moment I press the button, it's going to get up to 2.6 volts, which is also the voltage across the LED. Now, this is where you want to pay attention and you will understand what happens to the capacitor. Now, the LED as such needs, because it's a red LED, it needs 1.5 volts for it to turn on. And we talked about this in the last webinar as well. There, a diode is something which has a threshold above which it will allow current to pass through and below which it will not allow current to pass through. Now, the moment I let go of this button, you will see that it doesn't go to zero immediately. It is slowly discharging. Now the LED is already off because it's already below 1.5. But you can see that it still has some charge on it and it's continuously decreasing until it reaches zero. Now I can press it again and it immediately charges back up to 2.06 volts. I let go and you can see that it doesn't turn off immediately as it would without the capacitor. And you can test this out too. Let me take the capacitor out of this circuit. And if I were to run this, you will see that it turns on and it turns off. Turns on, turns off. Now, in case, and to understand again, this is using right now 0.22 microfarad, but I'm going to build this up. I'm going to say just 1 farad, right? I'm going to put this capacitor back in to the circuit, and we will hook up the ground back to where it was, and we'll run it. And now I'm going to press on it, and you can see it's still building up the charge. And you can see the LED is not really on because until the charge builds up beyond 1.5 volts, the LED is going to continue to remain off. And if you pay attention to this carefully, you will see that slowly the LED is going to get a little brighter when it gets to around the 1.5 volts mark. Okay, I'm holding down the button. I'm going to further hold down the button. And as it gets close to about 1.3, you might start seeing it slowly light up. And it takes that long. You can see the light LED is like slowly turning on right now. As it goes above and gets greater, you're going to see it get brighter and brighter. You will see it peak at a point where it's 2.06. And this time, given that there's such a large capacitance involved, it's also going to take that much longer for it to turn off when I let go of this button. There you go. You can see how it turned on gradually from 1.5 volts up till this point. And the higher the voltage gets, the slower it takes to charge as well. You may be able to observe that already. So now it's reached its peak voltage. I'm going to let go of this button, and it is not going to turn off the LED as quickly as we saw it turn off in the previously, and now it's going to take a little longer. You see, now I've let go. Voltage is dropping. Voltage is dropping. The LED is completely powered by the capacitor right now. And we can see it slowly drop further, slowly drop further. You can see the LED get dimmer right now. And our focus today is completely on the capacitor. If there are other parts of the circuit that you aren't sure about, feel free to let me know and we will discuss them as well. We intend to work on each one of these components separately and focus on them, including how to measure these voltages. Today, our focus is on capacitors. And you can see the LED is now completely dim. If you were to hold this down again, it would start charging again. And if you let go, again, it starts discharging from there itself. Now, you can play around with these capacitor values to get a better sense of how different capacitor values are, can be used for providing different amounts of time for the LED to be left on after it's connected. So now, as we do every time, we are going to now build this circuit on an actual breadboard. Now, just so that you know, the phenomenon of it taking time to charge and discharge is not as pronounced in an actual circuit, but it's always fun. So what we're going to do is build it, and right now I already have my breadboard, which is hooked up to my battery, very similar to what we saw on the Tinker Circuits tool. And that's a tool that I really like. Everyone should try it out and try to experiment with that. It helps you understand what works and what doesn't before you actually get down to building the circuit. So as we did, I'm going to put a button on there. I'm going to connect the button to the positive. Then we have a resistor going from the other end of the button to a separate row. I have an LED that's going in, and on the other end I have a capacitor, and this is a ceramic capacitor which has a ceramic coating. There is also an electrolytic capacitor, and we'll try that too. And then I'm going to connect the common row between the LED and the capacitor to ground. And let's see what this does. And you can actually take a closer look at this. Okay, so you can see the LED turning on. You could also notice that it took a little longer than just when I clicked on it for it to turn on. You see, I press and it turns on. That is just the little bit of time that it takes for the capacitor to build up the charge. When I let it go, because the capacitor is really small, this is 0.22 microfarad, it doesn't really show us that much of a lag when I let it go. It's not as pronounced as in the Tinker circuits, but it does happen. And if you have larger capacitors, it will be more pronounced as well. Let's try to swap this out with the electrolytic capacitor. The difference is you can notice that this uh, ceramic capacitor has equal sized legs, which means that it does not have a polarity. You could place it one way or the other and it would work the same. In this case, there's one longer and one shorter leg, and that means that it does have a polarity, and the positive end is connected towards the button, and you can see this works the same way. If I were to turn it the other way around, it would still work, but it would not have the capacitance involved because the capacitance would not charge in this opposite direction. You can actually notice how it takes a little bit of time for it to turn off. See that? The longer you hold it down, the more charge it accumulates, and a little longer for it to turn off. See that, right? If I let it go, it doesn't turn on instantly. And you can get larger capacitances and explore this further. Cool. So that is it for our circuit, and you should try this out with different capacitances. And also, feel free at any point of time to put in your questions at youngwonks.com/podcast. I'm going to be keeping an eye on that page so that in case there are any questions, I will be able to address them. So now, moving on to our discussion about capacitors, we did talk about what they would be used for. Now, one of the main things that capacitors are used for in a circuit is surge protection. And how does this protect surge? Because if the power source fluctuates on and off too quickly, the capacitor has charge built in to retain the state of the devices that are connected during that fluctuation. Another very important use is in camera flashes, because the camera flash is a very, very bright light which happens for instant. So storing charge in a capacitor and discharging it really quickly through a LED or a light or a grid of LEDs is another application for these capacitors. If you have used capacitors in your circuits for any other purpose, do let us know by putting in your comments at youngwonks.com/podcast, and do let us know if there are any other uses that you may have thought of. So now, coming to a conclusion, capacitors are essential in any electronic circuit. Whether you were to look at the circuit of a TV or any other electronic device or even electrical devices around you, you will see that capacitors are used all the time. And it's an essential part of every electronic circuit. So I hope that helped you understand capacitors a little better, and you now are interested in trying capacitors and understanding them better for yourself. We do have some blogs and videos related to this already on our channel, and do check them out. That's the YoungWonks YouTube channel, and also on other social media channels as well. That's it from me for today. Signing off. We will be back next week with another cool podcast, and you can keep track of the topics that are in store for you by looking at youngwonks.com/podcast. Thanks again from YoungWonks. See you again.